Yeah, the volume's okay.
That volume.
Okay. Shall I try to share slides, I guess?
Yes.
It says here, share screen. And then I can pick a window or the whole screen. Might be safer to pick the whole screen, right? I don't know what your recommendations are. Or should I try and pick the window with just the slides?
You could do the window and you can expand it and make it full screen.
Okay, so there's the window. And now I have to switch to it, and then slideshow. Does that do what you expect?
Yeah, that looks good.
Because now I can only see that window, so I can't see myself or anything else, but presumably that'll work. All right, so I'm up in a few minutes. Should I stay on like this, or
yeah,
this just
stay on.
Yeah? Okay. I might have some tea. Just give me a 30-second warning or something when we're actually live.
Just as a quick note, whilst the presentation hasn't started, this
You have 30?
Okay.
if I speak, will it switch back to my camera, or will it still be showing the slides over the top? Can you hear me okay?
Yeah, we can hear you okay.
Hello, my name is Hazel Smith. Welcome back, delegates from the lunch break. I'm going to be your session chair for this afternoon, as well as the Q&A monitor. There's a few points I need to cover. You've probably remembered them by now, but about how the Q&A process works. All questions will need to be in the workshops channel on Mattermost, prepended by #questions, and I will be reading these out for the speaker to answer. No questions for the remote speaker sessions will be taken in the in-room microphone. Talk ratings will be in a poll on Mattermost in the workshops channel, which will be active from the beginning of the talk until the end of the session. This is the only chance to rate the talks in this session, so please do make sure that you give us this feedback because it's very useful and we really appreciate it. Your timekeeper for this session is Pallavi Aras, and she will interject verbally during the talk if required if we're running close to or over time. I'd like to take a moment to thank Ranids and SOX as our workshop hosts, and to thank Centre for being a joint program partner, and VeriSign as the 2022 workshops patron. As ever, we couldn't do this without the support of our collaborators, patrons, and members, so thank you. I'd like to go ahead and introduce our first speaker. So coming up now, we have Viktor Dukhovni with addressing DNSSEC deployment risk. We can see your slides, Victor. Do you want to go ahead and start?
Sure. Good morning, everybody. It's still morning in New York at this moment. Thank you for joining. I'm going to talk about making it easier for operators of critical domains to consider enabling DNSSEC while managing the risk of things potentially going unexpectedly wrong. Okay, so I'm going to briefly go over the state of DNSSEC today, how things operate now. I'm going to talk about what kind of domains so far have largely stayed away from enabling it, the ones which are most worried about the potential impact. I'm going to describe some things we as a community can do to ameliorate that risk and maybe make it easier for more such domains to enable DNSSEC. And then I'm going to ask for folks to participate and help and take those steps, at least some of the steps that I'm recommending. Next. All right. So today, DNSSEC, of course, starts with the child zone. You sign. You do some testing. All of that is completely safe to do on your end until you go ahead and start telling the registrars and registry that you're ready to enable DNSSEC. The next step, of course, is to communicate your DS or DNS key records to your registrar. Often, at least for individual people managing their own domains rather than large organizations. You might be doing this through a web form. You might make a mistake in specifying the algorithm numbers, which you may not fully understand, or miscopy the hash value and so on. It's not clear that all the registrars will validate the data that you put in, even for syntax validity, let alone whether it actually matches your live zone. So there can be errors introduced at that point. And then, of course, the most critical thing happens, which is these DS records, correct or otherwise, are sent to the registry, which within a few minutes will publish them in the DNS, but often with a one-day TTL or so. And what that means is that if at any point a mistake is made, or even if no mistake were made, but for some reason enabling DNSSEC introduces an unexpected behavior in the critical application that you care about and need to remediate, you're down or have to manage degradation of your service for about a day. Again, the registry will typically just accept whatever the registrar sends. In most cases, no validation. As I've said, you sign and you hope that everything goes right. But if any of the things that are required to be done go wrong, you're out of luck. The DS records might be wrong. There's no timely rollback. The DS records aren't validated in most cases. And so the DNS zones that are most affected by even short outages are reluctant to deploy DNSSEC. Here's an example. I don't mean to pick on Ethiopia specifically, and I don't know that their concerns are exactly my concerns. But Ethiopia has been internally signed, as you can see on the right, for actually a couple of years now. You can go back in time and look at DNSViz and see that they've been signing with algorithm 8 now for as long as there are DNSViz records of Ethiopia, and then they don't have any older data than that. On the other hand, if we look at the root zone carries a denial of existence of their NSEC records. Ethiopia is signed, but not in fact DNSSEC enabled unless somebody has an explicit trust anchor for Ethiopia. In that case, maybe they can operate a DNSSEC just within that zone. But for the rest of us, Ethiopia looks like an unsigned domain. They haven't actually turned DNSSEC on at the parent for one reason or another. What's a critical zone? From my perspective, a critical zone is one where the users and customers expect always on service. So minutes of downtime can carry millions or more of dollars in damage, reputational damage, customers switching providers, and so on. Critical zones really don't like to make changes that can't be rolled out incrementally, one data center or location at a time, progressively. And they especially want to be able to roll back quickly if anything goes wrong. If the change you're making didn't work, instead of trying to fix it, you roll back to the previous state and you try and figure out what happened and try and make it again later better. But you don't futz around trying to make corrections. You want to recover to the working state immediately, as quickly as possible. As I've mentioned again, critical production zones, some of them you might guess associated with my employer, are not currently very eager to try DNSSEC in zones where downtime is simply unacceptable. 100, as close as possible to 100% uptime is essentially a business requirement. So what do we want to do about that? We want to make DNSSEC rollout be something that an operator of a zone where even minutes of downtime are a serious issue, be something that you might consider. In particular, and the most important thing we want is shorter initial DS record TTLs. When a registry, let's say the root zone, actually enabling DS records for Ethiopia or for any other important domain, be it a TLD or a very large business, needs to set short TTLs so that if anything goes wrong, the rollback can be almost immediate. In particular, if something does go wrong, in addition to the TLs being short, it should be possible to promptly roll them back, in particular when the appropriate EPP requests are sent to the registrar. The registrar needs to forward them quickly to the registry, and the registry needs to quickly update the TLD zone so that those short TTLs are effective. And then finally, and more complicated and will take longer to figure out how to do, it would be really nice in many cases if either the registrar or the registry or both did pre-publication DS validation. So let's drill into this a little bit. Short TTLs. My proposal is that DSRR sets get a short TTL after any change in the DS records, not just when the zone is first delegated or signed. This could happen during an algorithm rollover or a KSK rollover or any other time when there's high risk of potential impact due to some sort of error. This would be a good time to reduce the TTL of the DSRR set and then gradually, or at least after one more step, bring it back to the long-term value once it's been stable long enough. the initial TTLs I'd like to see are as low as approximately 60 seconds, maybe a couple of minutes, but not more. The TTLs can grow ideally incrementally. So, if your initial TTL is 1 minute, maybe after 20 minutes, it can become 5 minutes. Maybe after a few hours, it can become 20 minutes. And then eventually it can grow up to about a day or so if that's necessary. Maybe, in some cases, it can stop at an hour. I noticed that .org TTLs are generally an hour, while .com DS TTLs are a day. Varies a little bit between registries as to what we ramp up to, but the initial value should be low. A good time to increment the TTL, of course, is when resigning it. The TTL is generally mirrored in the origin TTL in the RRSIG. So what the registry might then do is, when the TTL is lowered, schedule it to be resigned after a somewhat expedited time, and raise the TTL at the point in time at which it needs to be resigned. There are questions about whether TTL reduction should just be by default for all delegations, or whether this is something that domains that specifically care for this level of service need to opt in for. I don't know. This is really something to be worked out, at the registrar relationship level. But it should at least be possible to do this, even if it's not on by default. And also, in principle, one might even signal some of this information via TTLs, let's say on CDS records or DNS key records, which might also facilitate validation of the proposed data. So these are questions to be worked out in the community. Prompt rollback. Of course, if the TTL is low, that's nice, but it's important that, in fact, when it's time to undo an erroneous change, that the action to actually publish replacement TRIAS records or entirely remove them also happens on the same sort of time scale or faster than the DS records. Ideally, this can be in as little as a minute or less. I noticed yesterday I had some issues with a machine that died in my domain, and I removed it from the NSRR set. It took about 5 minutes or more for NS records to get from me via my registrar into the publish.org zone. I don't know whether the delay was with the registrar or with PER or with Affilius, but somehow the time to update NS records was 5 minutes. Sometimes it felt more like 10. So this is a little too long. Ideally, we can work with registries to streamline this process. Of course, if rollback is to be prompt, because both DS records and their denial of existence are signed, any processes that create long delays to batch up zone updates, like whole zone signing every hour, every 5 minutes, or whenever, is potentially a source of latency in repairing problem changes. So ideally, registries would therefore be able to incrementally update zone signatures for just a small batch of records that came in a short time window, and do this regularly and quickly. I don't know whether timeliness of such changes is covered under existing registry SLAs from ICANN, etc. But it would be nice if there were knowable and met expectations around how long it takes to make DS record changes, whether they be positive ones to enable DNSSEC or negative ones in a sense to recover from an erroneous change. Pre-publication validation. I would like to see somebody validate DS records, DS record changes against, let's say, either the live zone or at least CDS records that are published by the child zone along with the request to publish DS through whatever registry interface there is. There are many possible ways of doing this. The registrar might, in fact, look up the CDS in the child zone and send them to the registry. The registry might probe the live servers, making sure that they're all consistent with the requested DS records. This is, of course, a much larger operational change than tweaking TTLs. So it'll probably take longer to work out what the best practices are in that space. But my feeling is that it should be possible for some or perhaps even most zones to have their DS records validated before they're published, so that the zone isn't accidentally bricked by an inopportune DS record change. Of course, sometimes we want to publish invalid DS records for various experimental reasons, or to deliberately have a broken zone that you can test implementations against. So it should be possible to either opt in or opt out of DS validation. It can't be enforced 100%, but nevertheless, it should be possible to have that happen. It is perhaps the case that such validation might be akin in some ways to registry lock, some special arrangement between a registry and the registrar, and the registrant that hardens the domain, and this would be a premium service of some sort, who knows. This is all to be discussed and worked out. One thing I didn't stress perhaps in the previous slide is that I know that there's an effort in the regex IETF working group to create a draft that allows the registrar to configure TTLs in the registry request, shorter or longer TTLs. I don't think that meets my ideal requirements for short TTLs, because it requires the registrar to drive the process very carefully and correctly. And that's one of the areas in which mistakes are likely to come in. I'd like to see the DS lifetimes really be very much built in and driven automatically as a side effect of all DS changes, regardless of any registrar activity in 3PP. Next steps. I would really like to work with early adopter registries and registrars to see this move forward. There are a lot more registrars than registries to address. And in many cases, much longer cycles to make relevant changes. So my best sense is that TTL reduction for DNSSEC enrollment is something that I would look for .com, .org, .dev, which is actually my employer's operated, and so on, to start looking into this and work with me and the community to pilot and refine these ideas into something that becomes eventually standard practice. Don't know how quickly it will move into the CCTLD space. If any CCTLDs are interested in exploring this process, please reach out. It would be great to see this available ultimately across all DNS registries. One thing I didn't mention is that not only DS records, but potentially also NS records and even GLUE should perhaps have reduced TTLs when they're changed, again, to allow easier recovery from errors. There as well, long TTLs can lead to long outages if the error is regretted shortly after it's introduced. And of course, I think these ideas need to be hashed out in regex IETF and in this forum, and perhaps in upcoming ICANN meetings and so on the DNS operations mailing list and wherever else people have ideas as to how to move this forward. I think it'll be important for the ecosystem to allow operators of critical domains to move forward with some confidence. We don't want to see outages on the scale and duration of what happened with, let's say, Slack roughly a year ago, where after introducing a problematic change, they tried to roll it back and didn't quite do that right. And then they had about a day or two of consequences that were suboptimal. So this is something we really want to avoid. Thank you very much. There is a related effort. Somebody proposed dry run DNSSEC at the previous IETF meeting. It feels to me a bit complicated, but the motivation is, I think, similar, to try and make it easier to introduce DNSSEC in a way that's lower risk. If there are other competing ideas that achieve the same goals, that's great. If you're interested in just tracking DNSSEC adoption, Wes Hardaker and I have a site that's tracking the growth of DNSSEC. In the next few weeks, we'll probably hit 20 million tracked DNSSEC signed domains, a nice milestone that will happen either by the end of this month or early into next month. If anybody wants to track my rants on Dana DNSSEC, I occasionally tweet. And it's time for questions.
Thank you, Victor. So, as you say, it's time for questions. So, just a reminder to our audience members, please post your questions in the workshops channel in the Mattermost chat and prepend them with hashtag questions, and we'll get through them first come, first serve as the best we can. I'm going to start by reading out the first question.
Sure.
Edward Lewis from ICANN asks, with the risk of errors in inserting a DSRR being what is to be mitigated, taking into consideration of the scale involved in popular TLDs, addressing this with a solution that results in many changes over time by the registry or registrar, specifically altering the TTL value over time, would seem to increase the window for concern. Wouldn't the DS check before record insertion be simpler? Wouldn't this compact the time of concern into a tight window, which will be desirable / predictable?
So, indeed, I want to see the DS checks happen. My feedback so far from registries has been that introducing DS checks is much, much harder for them to do than potentially considering lower TTLs. So in fact, I'm prioritizing this aspect because it looks like it can happen faster and sooner. And re-signing already happens periodically, right? When a domain that's updated isn't then left alone forever in the world where a TLD is signed, it has to be re-signed. So there are all kinds of timers already going on. So this is something that registries seem to be willing to contemplate. And it's much easier than doing live probing or any other kind of additional processing. So the answer is, it seems like TTLs are easier. Also, of course, it might apply to NS records, as I mentioned, and glue even.
Right, thank you. The next question we have is from Stefan Ubink from SIDN, who asks, how do you expect a quick rollback when the publication of a zone takes 30 minutes?
Why does the publication of a zone take 30 minutes?
No, sorry, they said, how do you expect a quick rollback given that the publication of a zone takes 30 minutes? Or when the publication of a zone?
Don't take 30 minutes to publish the zone is the answer, right? So changes in, let's say, .com and .org don't take 30 minutes. They don't do whole zone signing. They incrementally inject new signed data into an existing zone. So these zones are dynamic. They're not like sign the whole zone and republish. Obviously, sign the whole zone and republish and do it infrequently is not consistent with this model that I'm proposing. So it would be a big change for anybody who only does whole zone signing. That's just not the way to operate if one is to be nimble and be able to roll data back quickly.
So the next one I have is apparently not a question but a comment. Anand from RipeNCC says, RipeNCC does DS checks before delegation for reverse DNS delegation, but recently we lowered TTL of DS record to just 3600. This helps during problems and also speeds up KSK/CSK rollover. I would like to see more registries do this.
Right, good stuff. I just want to say that an hour is good for many domains. My own personal domain, a rollback within an hour, no worries. You know, email might be delayed for an hour. I'll get a coffee break and get it later. But you know, if we imagine Google.com being down for an hour, that's just not acceptable. So the hour is excellent stuff, but I still want to see TTLs that are substantially lower than that at the point of introduction, whether it's through opt-in or by default.
And I have one more question here from Wes Hardacre, who asks, couldn't an authoritative server be modified to still publish an RRSIG with a long TTL, but serve only short ones in the exponential backoff procedure to avoid more frequent listening? Validating resolver algorithms should actually still validate with a longer, but only use the shorter, if I recall. The question wording is a little strange, but...
Yes, I understand the question. Indeed, Wes is probably right. There was actually a chat about this not too long ago. Somebody asked on the Mattermost channel about a mismatch between the origin TTL in the RRSIG and the shorter TTL being present in the actual served record. This is uncommon. It goes against the RFC, which I think can be read to say that the two should be the same, although I'm not even sure that it does. I don't think it'll cause any known resolvers any grief, but it being a novel practice, it would have to be tested to make sure that indeed there isn't some strange resolver that gets unhappy when an authoritative server gives it a shorter TTL than the origin TTL in the RRSIG. Shouldn't be a problem. It's a perfectly fine idea. We'll just have to see. But yes, it could reduce the amount of re-signing that's needed. Potentially, yes.
Right, well, I think that's all of the questions we've had in the workshops channel, and it's time for us to move on to the next one, I think. Thank you, Victor, for your presentation today. Coming up next, we have Xiang Li with Ghost Domain Reloaded. Xiang, if you want to go ahead and present your slides. And just as a reminder to everyone, the poll will be in the Mattermost workshops channel. So please don't forget to vote in the polls. Xiang, do you want to full screen your slides?
Okay, is the screen okay?
At the moment, we're seeing your entire desktop. That's better.
Okay. Thank you, Heather. Hello, everyone. I'm Xiang Li, a PhD student from Tsinghua University. So in this talk, Ghost Domain Reloaded, vulnerable links in domain name delegation and revocation. We will describe a new ghost domain attack named the Phoenix domain. Phoenix domain could make revoked malicious domains continuously resolvable at a large scale. In the following, we will focus on how we find it, how it works, and measure this threat and discuss the mitigation. So in today's internet communication ecosystem, domain plays an important role. It provides a solid basis for multiple applications and services. According to Verisign statistical research, more than 350 domain names have been registered until now. However, domains cut both ways. They can also be used to perform criminal activities, such as botnet communication, phishing, and malware distribution. According to ICANN's report for August, they found more than 468 domains showing security threats in just 1 month. So to fight against malicious domain names, domain name revocation is adopted by registries or registrars. Security operators can revoke a malicious domain through deleting or changing domain name registration. So after revocation, domains are no longer controlled by the original registrants. For example, revocation has been used to seize malicious domains for a long time. Microsoft seized a .org to kill a botnet in 2012. US also seized a hacker forum in this year. Now, we wonder, how does revocation work? Actually, it is a reverse process of domain registration. When a client registers a domain, such as botnet.com, the registrar will add new name server records into the TLD zone file. Thus, the domain is delegated to the client and his name server. Then, during revocation, registrars can either remove the name server entirely by domain delisting, or change the name server to other controlled server called domain sinkholding. Then, through revocation, attackers should never get the original answer when querying his domains, thus killing some malicious activities with domains. But does revocation function as desired? I'm afraid the answer is not. Ghost domain broke this guarantee. In 2012, ghost domain was proposed by our lab and could make revoked domain names still resolvable on the resolvers. As shown in the figure on the left, attackers first make the target resolver cache his domain, such as botnet.com. And after revocation, registrars moved the name server on the com zone file. However, before cache expiration, the cache of botnet's name server is still alive on the target resolver. Attackers could query the resolver again and return a new name server record with a large TTL. Due to the implementation flaw, the resolver cached the new record and update the TTL to a larger one. In the end, the name server record could never expire, which violates the expectation of revocation. Attackers can always use the cache to query his domain and prolong the cache lifetime round by round. So with ghost domain, even after revocation, malicious domain can still be resolvable. And attackers can use it to evade domain takedown actions or to use the domain freely after the domain expiration. And after disclosure, ghost domain affected several DNS software, including Bind, PowerDNS, and so on. As a mitigation solution, the TTL field cannot be prolonged if the response from the authoritative server with the same data level. Therefore, the cache can only last for a TTL tab. So ghost domain is fixed. This time, 10 years later, same question. Does domain name revocation work as desired after we fixed the ghost domain tag? Unluckily, the answer is still no. Phoenix domain still breaks its guarantee with a broader attack surface. So what is Phoenix domain? Notably, Phoenix domain is also proposed by our lab, and the paper has been accepted by NDSS 2023. Phoenix domain also aims to make revoked domain names resolvable on the target resolver for a long time. It has two variations called T1 and T2, which are caused by two new vulnerabilities in either the DNS protocol specifications or implementations. Overall, Phoenix domain affects all DNS implementations. So before we talk about how Phoenix domain works, we care more about why revocation is still vulnerable. And we find that the entire attack surface remains unclear until now. We first review the DNS update documents and several DNS software implementations. We summarize the DNS operations, including cache search, cache insertion, cache updating, and cache expiration. During the cache searching, resolvers use the closest name server for queries. And after receiving responses, resolvers would check the data rank to update cache. If there is no cache, resolvers will store them directly. Specifically, cache deletion is a separate process from the rest. Once cache expires, records would be removed from the cache directly. However, ghost domain just exploit issues in the cache updating operation. We find the other operations like searching, insertion, and expiration still face some security risks. So in the following, how does Phoenix domain work? And there are two variations of two ways. For Phoenix domain T1, it exploits vulnerable cache insertion implementations. And before revocation, the attacker makes a target resolver cache his name server of a malicious domain such as botnet.com. And after revocation, when the old cached NS records is about to expire, the attacker queries the targeted resolver again and return a delayed response to the target resolver until cache expiration. So in this time, when the resolver receiving the delayed response, the cached records are removed from the cache. Then the resolver considers no cached NS records, and the new name server is cached, and the TTL is updated. And this action bypassed the record updating restriction because there are no cached records to compare. So attackers can perform this unlimitedly. So the cache could be alive all the time. And the technical details are not mentioned here. To summarize, T1 is caused by inconsistent cache use and check operation, because removed NS cache is just used in current resolution. So it should not be removed before the cache is before the response is cached. And for T2, before revocation, attackers also make the target resolver cache his name server records of a malicious domain such as bonnet.com. Differently, after revocation, attackers respond with a new name server of a subdomain. Since the subdomain hasn't been cached before, and the new name server should be stored directly. So in each round, attackers could delegate another subdomain of current exploited subdomain recursively. And the max depth of the domain could be more than 100. So the cache could be active for a very long time. So leveraging Phoenix domain T1 and T2, we test 8 DNS software and find T1 affects 4 software, such as Bot9, Keynote Resolver, and Unbound. T2 affects all software because it results from the defective DNS specification and conform to current practices of recursive delegation and recursive resolution. We also evaluate the Phoenix domain against 41 public resolver vendors, and all of them are vulnerable to T1 or T2, such as Google and Cloudflare public DNS services. And they have confirmed the Phoenix domain and fixed the issue. Besides, to evaluate the vulnerability of open resolvers in the wild, we collect a resolver list containing 1.2 million resolvers. After filtering, we identified 210,000 recursive. Although forwarders are also impacted by the cache, the recursive is our main target. So first, we conduct a short-term experiment to check out how many labels are supported, which affects the exploitable depth of T2. So we compare the cache status of 4 types of domain, including a legal domain, a Phoenix domain, a ghost domain, and a revoked domain. In the end, the results show 89% are vulnerable to T2. And even after 100 rounds, 42% are still alive, thus exploitable. We also conduct a long-term experiments to demonstrate how long Phoenix domain can be alive, using the same setting as a short-term experiment. After 1 week, results show 40% are still vulnerable. And even after 1 month, 25% are still exploitable, which demonstrate a broader impact. Besides, through the geolocation view of vulnerable resolvers, we find that the resolvers are widely dispersed and have an impact on worldwide users. So after we evaluate the impact, we also make a disclosure to all affected vendors, including 7 software and 15 public recursive vendors. And they assigned about 9 CVE IDs, we also propose and discuss 6 mitigation approaches with several solutions that have been adopted, such as revalidating delegation information when the delegation chain is broke or expired, which is also an RFC draft. So as a conclusion, we propose a new Phoenix domain attack through systematic analysis of cache operation and uncover 2 novel vulnerabilities can make revoked malicious domains still be alive. They are result from either poor implementations or defect to protocol standards. Because Phoenix domain conform to current DNS practices of recursive delegation and using the closest name servers, it has a comprehensive influence and affects all implementations. We also discussed the details with DNS software and recursive resolver vendors to think about the mitigation and help them fix the issue. In the future, we will also discuss with some of the editors to improve the DNS recursive process. So this is my share today. Thank you all for your attention.
Thank you very much, Xiang Li, for that talk. We're now going to take a few minutes for questions. Xiang Li, I see you've closed your slides. I don't know if you want to keep them on hand in case you have questions about the slides, but just remind everyone, please post your questions in the Mattermost workshop channel and prepend them with #questions. I'm going to start by reading out the first question. So Viktor Dukhovni asks, the T1 attack is a lame delegation for any resolver that tracks which zone a pending query was issued for. Expiration does not affect the resolver's view of which zone the answer is for. Does this match your understanding of the issue?
Okay, I also noticed the question in the Mattermost. Some details I just not mentioned when I describe how T1 works. The technical detail about T1 is the recursive resolver use cached NAT records to make outgoing queries, but when it expires, it deletes it directly from the cache. So when the response reaches the recursive, it just caches it
Victor went on to say, for T2, a countermeasure could be capping the TTLs of delegations with, quote, many, unquote, labels, say 5 more, decreasing exponentially with depth. Do you have any response or thoughts on that?
Next question. I just didn't describe how the 6 mitigation approaches works. As about the question for T2, we have also the mitigation called M6. It's just a similar countermeasure about the question. We can restrict the TTL of delegation with many labels, such as the max TTL of the SLD could be 1 day, and the subdomains TTL could be less than 1 day, maybe decreasing expositional with depth.
Thank you. I'm going to go on to the next question. Peter from Red Hat asks, can DNSSEC protected zones be less vulnerable to this kind of attack? Does the difference of signatures make any difference?
Good question. We talk about this in our paper in the discussion section. Actually, we believe DNSSEC can mitigate this attack in the beginning. However, attackers could use an unsigned domain. Yeah, he can register a domain by itself. So an unsigned domain just work as the DNSSEC cannot validate it. So DNSSEC cannot mitigate this attack.
So I don't currently see any more questions in the channel. I'm going to give a couple of moments in case somebody is typing to see if they finish a question. I'm going to give it one more moment.
Okay.
Mark asks, DNSSEC, oh, sorry, if they've said hashtag question, DNSSEC in applications can mitigate this attack. Mark,
Yes, okay, yeah, to be more specific, if the recursive turn on its DNSSEC and refuse any unsigned records, and the DNSSEC can mitigate this attack. But however, in default, when the recursive such as bind and unbound meet some unsigned domain, such as without a DS record, it cannot complete the validation process.
Right, well, I think that's all the questions we have time for. Thank you very much, Xiang Li, for your talk. And thank you to all of the speakers that we've had in this session so far. There will be a short break of around 25 minutes. We will be restarting at 15:15 CEST or 13:15 UTC sharp. I'd like to take a moment to thank our workshop hosts, Randis and SOX, and Center, our joint program partner for OARC 39, and VeriSign as the 2022 workshop's patron. There will be a end of conference survey, so please keep an eye out for that. The information should be on the rolling slides, and Keith will make an announcement about that later at the wrap up. See you all back at 15:15 CEST sharp for Jake Zach with Embracing SLAs, How Customer Requirements Drive Innovation.